Hi, everyone. This is Rich Berliner from Digital Locations. I'm here with two of my most favorite people in the wireless business, two giants in the industry, Ted Rappaport and Arjuna Madanayake. And uh, Arjuna is working with us at FIU on a project, but we're here today to really talk about what Ted is doing at NYU in his NYU lab. And Ted, I just saw a demonstration of what your students were working on, and I'm absolutely blown away on the progress they're making on 6G and the technology that they're doing here. Before we get into the project that you two are working on together, tell us a little bit about what we're seeing here today at NYU and what you're working on.
Yeah. Hi, Rich. It's great to see you again, and really nice to be back in touch with you. I remember working with you in the early days of indoor wireless. You were a big customer of mine when I ran the company Wireless Valley, and you were running Berliner Communications, deploying DAS all over the East Coast. So it's great to have you here on campus at NYU. This is our big week. What you just saw was the poster session for our industrial affiliates. We just completed our board meeting today. It's October 31st. Is that right? Yeah, it's Halloween.
It is Halloween.
2023.
Happy Halloween to both of you.
Happy Halloween. And we have no tricks, but all treats for you, Rich. And you got to see some of the treats. Our board members were circulating throughout the expansive NYU wireless research facility here at the NYU Tandon Engineering campus in Brooklyn. And you just got to see a couple of my grad students in my lab showing the latest research on 6G, channel modeling, precision timing, chip design, chip measurement, and kind of the fundamentals of what will allow the future of wireless, 6G and beyond, to happen. I'm just one of 20 or so faculty members, and we have $30 million a year of annual in-force funding from industry and academia, funding 60, 70 graduate students. And the industrial affiliate sponsors of NYU Wireless come the day before our big Brooklyn 6G Summit, which is tomorrow. And they basically get a full day with our students and with the faculty. And we plan and present on what we're doing and what we're doing in the future. Arjuna, I think you've been to one of my board meetings before, haven't you?
I have. That was a couple of years
ago. So 6G is not we don't know what it's all about. We're not sure. 6G is really coalescing around a certain number of ideas and philosophies that are going to this. Am I right with that, Ted? Is that accurate?
Well, yeah, you're right. The fermentation of the 6G fundamentals are happening in research labs like NYU Wireless. Now, the global standards body won't figure out what stays and what gets thrown off the shelf for another couple of years. The 6G global standards body, 3GPP, will start to work in about 2 years from now. But a lot of the fundamental principles and concepts and contributions are being made now and have already been made at NYU Wireless and other academic programs, as well as the research labs around the world. Yeah. So the standards process to make a new generation, a G and cell phone, takes about 10 years. And the first 5 years is kind of the research stage, while the earlier generation is just getting off the ground. And once it looks like the earlier generation, 5G in this case, as it starts to take root and take hold around the world, and it is happening, the industry starts moving forward on its 6G or sixth generation standardization process. And it involves years, many years, 4 to 5 years of monthly meetings by the 400 companies to start iterating on releases and versions that eventually lead to a new standard. So we'll see 6G probably around 2029, 2030 in its early carnation.
Yeah, that's what I've read, and that makes a lot of sense now, and I believe you because it's sort of the 10-year to a next G philosophy that we've always had in this business.
Probably 2027, you'll see 2027, the first release of 6G, but it'll take a couple more years after that to get around 2030 when it starts coming into products.
When I see an executive here that is from Dell, and he's the head of 6G, and from the equipment manufacturer Keysight, who's the head of 6G, I kind of get the feeling that this is no longer a joke in the industry. Yeah, 6G's out there. This is really happening. They've put real people in these jobs in these big companies.
Oh, yeah. I mean, you think about it, the design cycle to get commodity pricing on a market that has several billion people requires a lot of investment, and it requires looking ahead. Academia does that much better than industry. And there are places in academia like Arjuna at FIU, us at NYU Wireless. There are a number of good schools with dozens and dozens of grad students. You saw the army of faculty and students down our hallway. And so we're constantly working on the ideas and giving them to the few people in the companies right now, but there'll be a lot more people as 6G gets closer, starting to look at 6G. So academia has an important role to play in fermenting the ideas and making proof of concept ideas and promoting them and getting buy-in from other academics and early industry adopters.
All I can say to that is amen. So let's talk about the two of you. The reason I came here today, and I really wanted to talk with you, and I'm so pleased that Arjuna, who's working on our project, is working on something with you also. That's what I really wanted to talk about today. So tell me about the project that you're working on. You've just gotten massive funding for something that you two are doing. So tell me about it and tell me what the importance of that is.
I'm happy to do that, but I want Arjuna to first give his perspective on our working relationship, because I've been very fortunate to know Arjuna for a long, long time, even before he went to FIU. And it's been one of my more enjoyable collaborations as a professor. And I could talk about your research that we've worked on and that you do, but I want you to have some airtime to let Rich know about your history, because you may not know this, Rich. I knew him when he was in Ohio, and the neat things he was working on and trying to make DSP faster. So why don't you give a little bit about your history and then how we got to work together before we talk about our big grant.
So first of all, thank you for having us in this call today. I appreciate it, and it's nice of you to drive down from your home in New Jersey. So Ted and I have about 8 years of collaboration, very enjoyable. I consider him as a friend and a mentor, right? And yeah, so how we met, I emailed him and asked him to work with me, and he was kind and generous enough to say yes. So thank you so much for that.
Yeah, I'm glad I did. You're fun to work with. You're an idea guy and you make things happen. So why not?
So thank you. So maybe 8 years ago, we wanted to write a proposal to the National Science Foundation.
This is the very early days of millimeter wave, when no one even believed you could build adaptive antennas in a cell phone with multiple elements.
Right. And so we were, trying to put a team together, and somebody mentioned Professor Rappaport. I reached out, he said yes. So we jointly developed this great idea for the SPECIS program that was funded.
That was a National Science Foundation,
SPECIS program. Basically, we did some fundamental work on extending basic components like analog to digital converters or amplifiers, which are traditionally been two-port networks for the last, beginning of time, essentially, to something that is more suited for high-capacity wireless communications.
And if I could say, your research really, while it may not matter, it didn't then, it's going to matter, because Arjuna showed how you can use approximate DFTs, use approximations in digital signal processing and save 25, 50, 75% of the compute budget and create antenna beams and modulation and coding capabilities that are virtually the same as if you do the way we do today. And this is going to be very important in green engineering, sustainability, and conserving battery power, because the ICT industry is going to be 20, 30% of every watt consumed on the planet in about 10 years. So it was really good. And I was able to build the statistical channel model, NYU Sim, which is now the most used open source software for modeling the propagation characteristics at millimeter wave. It started a really nice collaboration.
Right.
So, and this is what we're working together on. with our project at FIU. This is why we are so happy to have Arjuna involved in that project. So I didn't mean to interrupt, but go ahead.
Yeah.
Right.
Arjuna's a great guy.
I agree.
So we finished that project with NSF.
And you were in Akron then.
I was in Akron at the time, yes. So yeah, and then recently Ted and I have this new infrastructure project for terahertz, where we are jointly developing a very state-of-the-art terahertz measurement facility based on in NYU. And yeah, as part of that, I have some work with Ted, but I'll let Ted introduce that project.
Okay, yeah. Well, it's very exciting. It's the largest grant in my career. It's $4.3 million. National Science Foundation provides $3 million, and NYU, as a requirement, provides a 30% cost share, which is another $1.3 million. And that $4.3 million goes predominantly to equipment that is creating the first of its kind national resource for research on terahertz chips, integrated circuits, and for propagation all the way up to 500 gigahertz. It's under the NSF Major Research Instrumentation, MRI, grant program. This is an annual program that the National Science Foundation runs. It's open, competitive proposals. They have about $50 million a year, every year, across every aspect of engineering and science. So it's very competitive. And we won the highest amount given a couple of years ago, $3 million. So we got 6% of the budget of this program. And we're working with some terrific faculty. Arjuna from FIU, Professor Zoya Popovich, who's an expert on RF amplifiers up to the hundreds of gigahertz range. We're working with Shuai Ni at University of Nebraska, Lincoln, who's a budding young professor who was actually my master's student at NYU before she got her PhD at Georgia Tech. And we're working with Hua Wang, who's an RFIC expert at ETH or ETH Zurich, who I did sabbatical with last year. I took my world's first sabbatical. It was actually on that sabbatical that I wrote the proposal with my star student, Dipankar Shakya, who you met, Rich, just in our lab. And this paints a vision, and it's a vision we're now implementing. And Arjuna
what is
on
the outcome?
call.
Ted, what is the product? What is the outcome of
and
this
you can look it up.
Yeah,
the outcome, great question. Just Google or search Terahertz Lab, THZ space LAB, Terahertz Lab at NYU. We're creating a one-of-a-kind measurement facility that the world can come to and measure their chips or check out radio amplifiers and send them to their propagation measurement sites to make channel measurements for propagation from 67 gigahertz up to 500 gigahertz. So it's a measurement facility. It's a measurement facility that will be shared, and we're going to be developing metrology, calibration measurement methods. And what's exciting is we have two of the biggest probe station manufacturers for RFIC design, both contributing as core partners to build the world's first 4-port circuit testing devices. 4-port chip test. Future wireless is going to have multiple antennas, multiple threads, multiple parallel paths. So being able to test 4 ports at the time has never existed. We can do 3-port and 2-port measurements, but having all this additional capability of 4-port measurements is going to create new calibration, new measurement capabilities for these frequencies. You can go higher and higher in frequencies that have more and more antennas, more and more LO and RF chains, to get more power consumption, get more energy efficiency, to get less waste. That's what the Terahertz Lab's doing. And it's very exciting. I've never had a grant this big. And so we're placing purchase orders. I feel like Santa Claus, and it's not even Christmas yet.
Yeah, I see some of the vendors that you're probably going to be placing those orders with out there. So I was really impressed with that. And Ted, I can't stress enough, and it's great that Arjuna happens to be coincidentally working on this project with you and working on something with us. That is just, for me, just a home run. It's almost like, like Christmas all over again, because I'm getting a twofer here. So I thank you for taking the time to talk about this today. Thank you for having me here at NYU. It's an amazing, amazing facility. And so I couldn't be more thrilled. And I'm really honored to be considered a friend here to both of you. And thank you for taking the time. I know this is your busiest week of the year. You've mentioned that once or twice. And so thank you so much for taking the time to talk. We'll talk again. Hopefully we'll be able to spend more time together as you spend more time here in New York. And let's talk again soon. But thank you for your time today. Arjuna, thank you for being here for this. And I will see you in Florida next week. Take care, fellas.
Thank you.
Great to see you.
Good to see you.
Take care.